Hi guys, this is Mrs. Gastler, and in this video we're going to talk about Newton's third law of motion. You've done some labs, you've talked about the first law, so this time we're going to talk about the third one. I know we skipped the second one and it's weird, but we're going to use some Cornell paper. We're going to talk about Newton's third law, and this is what we're going to do. We're going to state the law, and then we're going to talk about what it means for objects. Okay. This law is also called the action and reaction law. That's a good way to remember it. It's about action and reaction, okay? And this is what it says here. It says, I'm going to add to what you might have heard before. For every action force, there is an equal and opposite reaction force. See how I wrote it in caps? You should do that too. It's pretty important. And that force is equal in magnitude, which is a fancy way of saying size, and opposite in direction. Okay? So I'm just going to doodle right here. If I have this object and this object, we'll call this one A and this one B, and A pushes on B, there is an equal and opposite force that is equal in magnitude and opposite in direction on the other object. Okay, so when there's one force, there's another. That's what this one says. They always come in pairs. Forces come in pairs. Okay, so what does that mean? Well, that means that when object A, we just kind of drew that picture, when object A pushes on object B, you should draw that picture too if you want, then object B pushes back. Okay, now these happen at the same time. Once object A stops pushing, so does object B. They happen at the same time with the same amount of force. So if B pushes with 500 newtons, then A pushes with 500 newtons. They're always the same, but in the opposite direction. Okay, so it's going to push the other way. That wouldn't make sense for it to push in a different way. In the lab, you had the spring scales and you were pulling on them, and they were always reading the same amount, no matter who was trying to pull harder or less. It always worked out to be the same amount. Okay, how to apply? All right, so we're always looking for pairs. When you're looking for pairs in an action-reaction, it's pretty easy. You take your action, you switch the objects, and change the direction if one is listed, or if it's necessary. Change direction if necessary. And then that's it. That's all it is. Now remember, it's always about forces, so we're going to do an example here. The action is Earth pulls Mrs. Gastler down, so that's the gravity force, right? You could say Earth pulls with a gravitational force on Mrs. Gastler down, and we could even say the amount. But the reaction to that, so what I'm going to do, this is going to be fun. So here's my A, and here's my B, and there's my direction, okay? So I'm going to switch A and B. So Mrs. Gastler, and keep the force, pulls, and now it comes A, Earth, and I don't pull Earth down, I pull Earth up. Okay, so that's the reaction. It's pretty easy. Just switch them, change the direction if necessary. Okay, now there's one more thing that I want to talk about related to forces and Newton's third law, and that's the reaction versus the result. Lots of people get Newton's third law wrong because they say, oh, when you kick a ball, the ball will go. Well, that's true, but that's not Newton's third law. Newton's third law says when you kick a ball, the ball kicks your foot back, which is why you can feel it. Okay, the reaction is a force. The result is what happens next. Newton's third law doesn't tell us what happens next. So I'm going to put not Newton's third law. Whoops. The Mythbusters. I love the Mythbusters, but they get this one wrong all the time. They use Newton's third law to talk about the result, but it's not. It's not about the result. Okay? So you're going to do some practice here in a little bit. If you have any questions or you're not sure what you're supposed to be doing, make sure you ask your teacher. Thanks for watching.